Alrighty, welcome everybody, and a very happy Friday to you. Great. Yep, I'm officially streaming. Alright, so I'm recording this, gonna put it up on YouTube, but I don't anticipate anyone ever watching it. Google Code Jam 2018 is coming up in a couple weeks, so I'm gonna run through a lot of the old problems. Goal is to solve one problem. I got an hour during my lunch break. So I'm going to introduce it, but I'm not going to spend a lot of time explaining it. I'll link you to it on the YouTube video and in Twitch chat, if anyone's watching, which nobody is. Okay, so we're looking at 2017. Can you see that? Yeah. All right, 2017 qualification round, problem A, the oversized pancake flipper. Now, to be completely transparent, I spent a lot of time thinking about this weekend. Didn't have my computer with me when I was on vacation, so I spent a lot of time thinking about this problem. Basic situation is this. On the input, we have got a set of pancakes, an array of pancakes specifically, that are flipped. So they're either happy side up or unhappy side up. We want to get all of the pancakes to happy side up, but the flipper that we have to flip them will only flip 3 at a time, or n pancakes at a time. So, given some set of pancakes, some array of pancakes I suppose, or list in this case, with certain ones flipped unhappy side down, what's the minimum number of flips needed to get it back to the right state, given our oversized flipper? If it's possible, output that minimum number. If it's not possible, just say impossible. So, you're linked in the Twitch chat to that if you want it. I'll also put it in the YouTube description so you can read this question. Anyways, through thinking about this is totally a Dijkstra's algorithm question. There may be a simpler way to do it, but what we're going to say is that given an initial set of pancakes, that's our initial state, and we can flip, using our pancake flipper, some number of pancakes. So we can make, let's say, 10 distinct flips at any given time. So the result of that flip is going to be a neighbor of our initial node. And then each one has its neighbors. So we're trying to route from our initial state to the perfect state, which is all of the pancakes in one configuration, so all happy side up. So the minimum number, that's totally just pathfinding. So we're going to Dijkstra's algorithm the crap out of this. So I'm going to be using Java. The goal is to do things just as if I were doing them at work. So I will be refactoring mercilessly. I will be doing my best to write tests before necessary, right? So let's do some TDD. I will be architecting this way harder than I need to, so it'll be done well, way harder than it would need to be if I was just writing this for a quick and dirty code challenge. All right, great. Any questions? Nope. Great, let's do this thing. Okay, so my input here, specifically right here. So the first line will be t, which is number of test cases, and then I will get a string that's minus, 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 plus, minus, plus, plus. And let's see, is plus good or bad? So plus is initially happy, minus is initially unhappy. Okay, great. Okie dokes. So let's write up my driver really quick to pull that in. So I'll make a new Java project. Great, project name, pancakes. Yes, of course I want to open it. Why would I ever not want that? Okay, perfect. Okay. Not what I wanted. Let's get a new package. Pancake.driver. New Java class. Great. So we call driver. So driver is just gonna pull in stuff on main. It's just like, oh. Blah, 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 blah. Alright, I have not done input-output for quite a while, so here we go. And test case is equal 0, what the heck? Let's do a buffered feature. Dude, I don't know how to do this anymore. Let's do this. Well, let's do this. System dot in dot readint read. No, that's not right. Oh gosh. Oh, it's scanner. Wait, scanner S. New scanner. System in that it? Oh gosh. Dude, this gets so long. Alright, what do you need, scanner? Yeah, of course, control zero, import.
Hey, Chris.
Hey, what's up? Oh, welcome to work. I'm currently on lunch, streaming some programming, because that's a thing I do now.
Nice.
Let's do start next int. Perfect. Informing angle 0, I is less than test cases, add mas. What's my input going to look up like next? Where'd you go? Input, where'd you go? Here you go. It's a string, and then space for the size of my flipper. So string for the initial configuration, and then space integer. String initial config, equal s dot next string. As it does next. Let's try that. And then int pancake size, flipper size. Equal s dot next int. Okay, let's try that. Okay, now in this case, what we're going to want to do is we're going to say pancake configuration, pancake configuration. I'm totally going to rename this, don't you fret. We're going to pass in initial config and flipper size. Okay. Okay, so pancake config doesn't exist yet. So let's create that. This is going to be in pancake. Let's just put this right in pancake. Okay, that sounds great. Okay. Not even. Okay, let's do this. Let's do. Yeah, we'll change that. But let's just config. Final int flipper size. Let's generate a constructor. That's Control Alt S. Generate constructor using fields. That looks great. Okay, and of course we don't want to call the super constructor because that means nothing to us. Okay, so given an initial config and a flipper size, I'm thinking that that initial config should probably just be an array of booleans. It seems like the most reasonable thing. Let's just verify in the problem statement if an array is going to be too big. So S right now, every character in S, okay, so S is the length of the pancake array. That maxes out at 1,000, so I can definitely just make that an array. That's not going to be a problem at all. So let's do this. Let's do private final boolean array. And that needs a name. Let's just call that pancakes. Yeah. Okay, so this initial config I'm actually never going to use, but I'm going to create the array. So let's just say pancakes equal to create pancake array. Create pancakes with the initial config. Initial config. Make that. That's Control 1 to bring up the suggestions, and then that'll make me a method. Boolean array. Let's just do this. We'll say pancakes is equal to new boolean array, and the size needs to be initial config dot length. Initial config dot length. Yep, that'll do. Okay. Now we said that was final, and we don't actually want that to be final in this scenario, because I want to do this in a separate method, which is fine with me. Yeah, that's fine. Okay. So then, we just go for, I hate doing this, I need the index, so I'm going to do it in for loop. I would prefer to do it otherwise, but yeah, it's fine, we'll shoot this way. So we'll just say if. Okay, new plan. Ready for this? So we'll do character array, cars. Car array. Okay, so what we're going to do is we're going to take this lovely initial config string, which is just a set of pluses and minus. We're going to make it into a character array, just so I can iterate through it. Okay? So we'll just say, we'll use a ternary here, even though I hate ternary. So pancakes of I is equal to cars of I is equal to plus, then plus is going to be true, else it's going to be false. Okay, so if it's plus, great. If it's not, bad. Okay, and then we'll just return pancakes. Cool, that's lovely. So we've made this pancakes. We've set the flipper size. Okay. And then, just for testing purposes, we're just going to be able to return that Boolean right now. Get pancakes. Return pancakes. Come on, buddy. Return pancakes. Okay, I'm going to write some tests on that just to make sure that this part here is working appropriately. So let's pull that off really quick. So to make new tests, first I need to make a test directory. So I'm going to right-click Pancake, new source folder. I'm going to call it Pancake Test. Okay. Then here in Pancake Configuration, actually I'm going to do it up here. We're going to right-click, say new JUnit test case, and I'm just going to change the source folder up here to Test. And that'll make the Pancake Configuration test right there. Yeah, sure, like that. Okay. So we're going to say Pancake Configuration P, and the new Pancake Configuration. So I need an initial config, and I'm just going to go plus minus plus, just for now, right? Flipper size is not used right now, so we're just going to pull that. Okay. So I've got my hotkey set up, so Control-3 will run this test. No, I don't, but I'm about to, so I'm going to import really quick my preferences file. General preferences from, it's on my desktop. So hit up desktop, I've got pref.apf. Great, there's that. Okay, good. So Control-3 should run this test.
Another one for you, Miles.
Cool.
Run as
Is there a backup
test.
or export?
No, I meant food-wise.
Perfect.
Oh, yeah,
great.
right.
Okay, so Control-3 is
Where'd you guys
working.
go today?
So no errors on that.
Special
So I'm going to say p.getPancakes, returns a Boolean. So let's just say
and
assert array equals.
Special what kind of food?
So the expected is this new
basically
Boolean array. It is going to be what? True, false, true.
So they labeled everything after.
False, true.
It's just the multiple.
So how you initialize an array?
Really?
And get p.getPancakes.
Sounds really small.
Yeah. No, it's
Okay. So that works. Assert array equals. This is what I expect. This Boolean array of true, false, true, and I'm expecting that to equal get pancakes. So run that, and that looks good. Okay, so let's give this a reasonable name. That's stupid. Okay, let's test string initialization. That's a weird name, but that's fine. Okay, let's do a couple more here. Just make sure we're fine.
Yeah.
So let's say p equals new pancake config.
Yeah, I mean, if you're looking
let's
for
just
another
do
random one to try out, that one's
minus,
and they have like their own
5 minuses, 3, great. Here's the thing, this isn't testing anything new, so I'm not super worried about it, so let's not do that. What do I need to test? The empty, probably not going to get it.
It's like $5.
You know what, that's probably sufficient for my needs right now. We know that given a valid one, we're interpreting it correctly. That's probably sufficient for my needs right now, so we're going to leave that. Okay, so I can now initialize the pancakes, and I've got that. So what I need now is a way, since you're going to be Dijkstraing this, I need a way to find out all of the neighbors I can create with one flip. Okie dokie. So given a pancake configuration, which has its pancakes, I need to get a bunch of neighbors. Am I spelling pancake right? You look at those words for long enough that they're just like gone, you know what I mean? So pancake looks silly right now. Okay. I'm going to rename pancake configuration just a pancake right now. It's one pancake. It's really a set of pancakes, but I'm just going to call it a pancake. Okay. Great. One pancake. I don't love it, but we'll get back to it and refactor it later. Okay, I need to get neighbors. So this is going to return basically a list. Should it return a list of pancakes? Now, I don't really need that flipper size, but yes, I do want to return a list of pancakes because that'll just make my life way easier. If one pancake knows how to find its neighbors, we're in business. So what we need is additionally a way to make a pancake with the Boolean array. Array pancakes, flipper size. Okay. This stuff flipper size equals flipper size, and this pancakes is equal to pancakes. Okay. So I can create pancakes using that. Now, I don't really love having these two constructors. I would prefer them to be factories. So let's do that really quick. Public static pancake from string, right?
He said you'd be down to do it.
So I got
But
these.
he just keeps coming in so late.
Let's just say that do array pancakes. Get to that. And then we're gonna make a private constructor really quick. Let's do private pancake, which let's make it this guy actually. This guy needs to be the private one. Okay. Yeah, we'll get there. Yeah. Sure. We're going to return new pancake with pancakes and flipper size. How's that go? What are you complaining about? Can I make a static reference? Yeah, let's make that static. That sounds reasonable. And boolean array. Now I don't want this to have the same name as that static. So let's make that. Oh gosh. Yeah, I can have the same one. It's fine. It's static. So make pancakes right there. Great. Now what are you complaining about? Return that public static. Oh my gosh. Pancake. Pancake from string. Okay, that's great. Now I'm just gonna hurry and make a pancake. This is gonna be private, so that's probably okay. Okay, that's great. So let's go update my test really quick. It's equal to pancake, pancake from string. Okay, how's it looking? Okay, that's all passing, so still working. Okay, great. So we need basically public list of pancake, get neighbors. Okay, so this is a given one flip of the oversized flipper. Create all the viable neighbors. Now I will have to make something outside of this class that like governs all of this. Java util.list. Let's not be monsters here. Also, I think this text is big enough for y'all to read. If not, let me know. Also, if my lovely face is in the way, let me know there too. See what I can do there. Okay, so here's what we need to say. Okay, this is what we're actually gonna have to test hard, but yeah, screw that. Let's actually write some tests really quick to make this work. We'll do those first, actually. So control test neighbors. Neighbors. Okay. So let's make a pancake. Pancake from string. Let's rename that. Just be from string. Whoa, why didn't you do that? Why'd you complain? Yeah, you need to be from string. Oh, what is going on? Okay. Okay. So we're gonna get pancake. Now from string. Okay, and so let's just do this. Let's do plus, 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 and our flipper size of 1. Now, specifically, our flipper is never going to be, what's up, Mystic Power 2? Who are you? What is your true identity? I miss you, but I don't know who you are. Okay, so pancake from string. So we're going to get a list of pancakes. List of pancake neighbors is equal to p dot get neighbors. Bother. Okay, so first things first. Yeah, import the list. Why are you a monster? Okay, so assert equals. We expect this list to be of size 3. Should be 3. Oh, that's stupid. Neighbors dot get size dot size. Yeah, that's the one. Trevor Paulson. Holy crap, Trevor! Good to hear from you. Dude, last I heard you were a realtor on the island of Hawaii or something like that? Or maybe you just got married in Hawaii? Either way, I saw a picture of you in Hawaii and you looked like you were happy. Good to hear from you, man. That's crazy. On the topic of Trevor Paulson, I played basketball this morning with some old guys. And yeah, I was way winded. I haven't played in too long. It was fun. Alright. Anyways. Okay, so we're going to assume that the size is 3. That's going to come back false. Great. And actually we got an unresolved compilation problem. So let's go there. Alright, get neighbors. Not returning anything. Okay. So let's do some work here. Okay. So here's the scenario with these flips. I've got this Boolean array of pancakes and a flipper of size n. So
I don't have a preference this time.
we need to flip as many times as we can. So okay, int number of flips. Flips. This is just going to be the length of the array, so pancakes.length minus flipper size plus 1. Now I despise having anything ambiguous in order of operations, so we're going to put those in parentheses even though we didn't probably need them. I'm sure we didn't actually need them, but it's all good. Alright, so number of flips equals pancakes.length minus flipper size plus 1.
What's that?
We go 4 if I equals 0, I is less than number of flips, I plus plus. Here we go. Okay, now here's the situation. I don't want to mutate my pancakes array here.
I think you didn't need it.
I'm gonna need to mute it. Let's make a new one really quick. Boolean array temp. Yep, that's bad name. Is equal to arrays, copy of. And we're gonna pass in pancakes. And the second argument I think is the start time or is it the end time? Just copy of. Int new length. Oh, great. So let's just do pancakes.length. Pancakes.length. Okay. So I think we're just gonna clone that one. That should do the trick. Who knows if that's efficient or not? I don't. Nobody cares. Okay, so temp is the one we're gonna mutate. Now we're starting at 0. So what we need to do is flip the next. Oh, this is easy enough. Okay. So for oh gosh, int j is equal to 0. J is less than number of flips. J mas. We're gonna say that temp of I plus j, right? So yeah, let's try that. Is equal to pancakes of I plus j. So it needs to be not pancakes. Okay, so we're just gonna negate that. Okay. So what that's gonna do, and then we're gonna say, there we go. List of pancake and neighbors. Let's do a new list of pancake. This is going to be an array list of pancake, and it's going to be included with the number of flips. Now, of course, that's not created yet, so we're just going to hit Alt down to move that down. Okay, so then we're just going to do neighbors. Add pancake. Actually, I can do this new pancake. We have temp. We have number of flips. Flipper size. Sure. Okay, and then here we're going to return neighbors. Cool. So that's my untested, happy implementation of get neighbors for pancakes. So let's run this test and see if we get the right number back. Okay, array index out of bounds exception. That was lovely. Okay, so temp of I. So the number of flips. Let's find out what number of flips is coming out to, shall we? I've got control 4 set up to debug my unit test. So I'm gonna hit control 4. And let's see what number of flips came out to be. Number of flips is 3. Yeah, that's pancakes.length, right? It's 3. Flipper size is 1, and then plus 1. So if I've got 3 pancakes, right, I can flip the first, the second, and the third. So yeah, it should be 3 flips. Okay, so here we go. Oh, and F6 goes to the next one. So I make this temp, which has 3 size. That's great. J is 0, J is less than 3. Ah, that's going to be problematic. Flipper size is 1, number of flips is 3. Okay, J is less than flipper size. That's where we go. That was my problem. Yeah, I was trying to flip too much. Let's hit F8, that shouldn't break. Let's see how we did. Okay, that passed. We're green, so good. Okay, and you know what? That's not too bad. That's not too bad. Okay, so here we go. Neighbors.size. Okay, we need equality on our pancakes. So let's regenerate equality here. So generate hashcode and equals. Yeah, just go for it. That's great and dandy. You look good. That's Eclipse generated code, so you know it's good. Okay, so let's do this. Let's just say assert true. And we're going to do neighbors dot contains new pancake from string. We're going to have it start out as plus minus or plus with plus, so I'm going to start. Okay, that's definitely a neighbor. And flipper size of 1. Okay, and while we're in there, let's just verify that it contains this guy and this guy, right? So that should be the 3 neighbors that were created by doing that. Right? And that is correct. Great. So I am now generating neighbors correctly for this one simple pancake. So that is neighbors with flip size 1. Okay, so let's just make sure we can do that for a slightly larger flip size. So let's go crazy here. We're gonna make this. So that's 6. That's gonna be annoying, but okay, that's fine. Okay, so let's talk about all of the neighbors I can make off of that. Let's just do the brute forcing here really quick. Okay, so we can do minus, minus, minus. We can do those 3 replaced. We can do the next 3 replaced. And we can do the last 3 replaced, right? So those are the neighbors we can make right now, right? So let's just go ahead and put those into the code really quick. And it's a flip size 3. Yeah, so we want that to be 3, okay? So that guy's done. Yeah, it's gonna be size 4, not size 3, but we'll deal with that in a minute. Just getting this code in. Okay, and then one more. How do I duplicate Control Shift down? I don't know what duplicate is, so I'll just copy and paste it. Here's a keys for it, but I don't know what it is.
Okay.
Okay, let's go 3, 3, 3, 4. Okay, let's run that, and that's passing. Okay. Who is this incredibly handsome programming man? One of my loyal viewers asks. You're probably talking about the guy in the back. That's Alan. He's fantastic. You may be able to see Mac behind me. He is a handsome QA man. Ladies, he's available. Since I have so many ladies watching this stream.
Oh, really?
All right. So neighbors are coming up correctly. I'm initializing correctly. So now, given a set of neighbors, I need to build my, oh, Ben, you're too flattering. You are too flattering. Alright, well, let's make this run. Pancake? Oh, we just named those pancakes. Pancake. Pancake, is that right? I don't have that, so let's just do... Oh gosh. And folks, do we have any meetings today? I don't think so. It's the end of week 1, not week 2. Okay, great. So get a pancake. We'll deal with that later. So at this point we ask, what do we do next? Well, I need to add a driver that can run basically Dijkstras on these pancakes. I don't know what class that's going to be named. So given a pancake, I want a new class that is going to track all of this. And I'm going to name this one Edgar, or Edgar Dijkstra. I don't think I'm spelling it right. I'm definitely going to refactor this, but so I haven't done this before, so let's just make it happen. Okay, so here's what this class has to do. Given a pancake, given a pancake, that's a capital P, pancake, determine if we can reach optimal status. Reach the happy configuration.
Right. Okay.
Okay, so quick review of Dijkstra's for you. I'm going to link the Dijkstra's algorithm in Twitch chat. So Wikipedia, search Wikipedia, whatever. Wikipedia, whatever, search Dijkstra's algorithm.
I think it's important for us to be
Dijkstra's. Okay, here's the link to you.
Twitch
chat.
the
Twitch chat, here's Dijkstra's. Also, whether or not you saw the link to the question, here's the link to the question. Okay. So Dijkstra's basic rundown is this. Start at one node, take a look at its neighbors. You have a set of what we call visited nodes and unvisited nodes. So everyone's unvisited and everyone has a temporary distance of 1,000,000. So we need a private set of pancake. This is the unvisited set. Unvisited.
Yeah, and I think
preset? Hash set? Doesn't really matter. Hash set of a pancake. This doesn't have to be ordered, so it's clearly not a preset. It's a hash set. Private set of pancake, which is the visited set.
Yeah, icons and
okay. And then we need a map from pancake to int length integer. and this is the distance map. Distance
where we
map,
need-
map of pancake
Be replaced.
to integer. Okay.
We're at the point where we just need business input. And we can
Okay,
do is we
so, we
we
need to know, are we the happy pancake? Okay. So we need to know if we're the correct pancake. So let's actually build that into pancake really quick.
Gotcha.
So let's just do public
So it looks like that's
is
you don't have
happy
by
pancake.
default. So by default, it's on here.
And to be the happy pancake, you need to have all of your pancakes in the plus
just by
configuration.
default. Vimo has two other options.
So, here's what we're gonna do. We're just
there
gonna
was
do
a bug
four.
that I fixed earlier
Four.
that was merged in where
Boolean
it was
b
looking
in
at-
pancakes.
it was trying to
If
find
not
old
b,
report templates and put in the new
let's do
one.
this. Boolean
And,
happy
there
in
was
pancakes.
a bug in how it
If this guy is not happy,
turned,
then say if
so
he's false.
there was always a Vimo
We're
plus
going to
default,
return
and
false,
default
and then if
show
all of
up
them are
under
true, we're
that,
gonna return true.
Um,
Easy peasy peasy. Public Boolean. This needs a return
That's
type.
the,
Of course it needs a
solve.
return type, you monsters.
Yeah, they would
Okay,
do
so let's
that.
hurry in, write some tests
Yeah.
for that.
So then I fixed that, and so now
Let's rename this from pancake configuration test to pancake test. Abort.
Yep.
Pancake test. Good enough for me.
Just doing a URL
Okay,
compare
let's do that test real quick.
to a non-URL compare that has
Apply
the correct
test.
listing, so I just made the whole URL escape and then.
Pancake p equals
So that-
pancake
that's
dot
prevent-
from string.
Because before the Vimo default was showing up,
Two.
Vimo plus default was showing up with this.
Assert
It wouldn't
dot
have that
assert
return
true
set.
p dot is happy pancake. Great.
I'll address those
That's
comments, just
working.
removing those things. I don't know about this stuff.
Pancake dot from string.
It might make sense to
minus
yeah,
plus
make that an option
3.
for
No one cares about that real quick. And then we'll
Yeah,
just
this
assert
is
true
kind of
p
arcane.
is happy pancake.
some of the stuff.
Let's just make sure that comes back
but-
false. Assert false.
Yeah.
Okay, that's passing. So we're in business.
Yeah, I'll remove those comments.
Okay, so let's go back to Edgar, who's going to run Dijkstra's for us. So the way that Dijkstra's works is you have this unvisited set and a visited set.
Yeah, okay.
So we start with the pancake. So public int solve pancake,
Yeah.
and we get a pancake in, which is the
That makes sense.
source pancake, the
And
origin
again, I
pancake.
might not listen to
Start with the origin, right?
Solves, and so it's like,
Okay.
but
I think that's actually like it's not that big a deal.
I think you're
I'm
right
gonna
there.
not read all of my messages. Okay. Return -1 generally. Oh, here we go.
All right, cool.
Okay, so here's how this goes. We'll just say unvisited,
Okay. How are fonts?
add origin. Great. Start with that. So if origin dot is happy pancake, return 0.
Yeah, there's.
That's fantastic. That's the distance to the pancake.
I have seen something with where we set like, the
Do-do-do-do.
universal look and feel.
I'm gonna try to
Styling how
stop
it's
showing
on
messages
your-
from my
on your-
life.
Yeah, if you look at
Okay.
there's like
So here we go with this. We need to go.
desktop launch.
Okay, let's get all the neighbors. List of pancake neighbors is equal to origin.
Like just
Okay,
this.
neighbors. Okay. Close around. Yeah.
Oh,
And then I want to say if for
here.
for pancake neighbor and neighbors, if this neighbor is not in the visited set, if not visited dot contains neighbor,
Yeah, like there's. I
we
don't
want
know.
to say unvisited dot add neighbor.
I think the UI manager is where you can set fonts and that's
We want to
Yeah.
say
And what I'm thinking
distance
is,
map.
the reason I'm thinking that there's a way to do it universally
Okay,
is that there's
this is going to end up being a
kind of
little bit silly.
I would suggest
Yeah,
we have
turn
a block
distance.
somewhere that would be say, you just
So-
want it. And it's not on the
Turn
buttons or
current distance. Let's try that.
Yeah, and I think you need to like
Set current distance. Let's just try that.
in this one.
Yeah.
So that way.
Okay, so we need to put in this distance map.
Because I think Ubuntu just doesn't have
We
the
need to say
Right. It's, yeah.
if distance
And what's interesting is these are not.
Ubuntu font.
not distance map
Yeah. You guys
is
use
key neighbor.
Maybe we're not.
And so distance map dot put neighbor and
Okay, yeah.
current distance plus 1.
Which,
Okay, so we're going to say
I don't
this
know,
guy is
it's
clearly,
not
this new
reasonable for
neighbor,
us if we
is
have to go
1
through
away from our current node, right? So current distance plus
Yeah,
1.
and the UI
That makes a lot of
manager
sense.
can set fonts on.
If he does contain it,
What I
we'll
find interesting
say,
is these. This is
it's a bloody integer.
Ubuntu font.
So we'll say
So there's
integer
Figured it out for that. So.
Yeah, I would guess might just set font on here.
Integer current distance, all distance.
So
Is equal to distance map dot get pancake neighbor. Neighbor is the key. And then if all distance is greater than current distance plus 1, we say that distance map dot put neighbor current distance plus 1. Okay, a couple things, right? So this current distance plus 1 is getting thrown around a lot. So why don't we just actually, okay, we're gonna ignore that condition for a minute.
no, it's actually preview.
So we're going to say that int current distance, new distance. Okay, I hate using new, so I'm going to call it nuevo distance. It's equal to current distance plus 1. And we're going to just use nuevo distance everywhere here. Right? Greater than nuevo distance. Now, in traditional Dijkstras, there's like some cost of going from one node to another. In this particular setup, the cost is always 1. I've been streaming for 35 minutes, so I got 25 minutes to solve this thing. I think I'm making good time. Maybe a little slower than I'd hope, but this is what I practice for. Okay, so let's not talk about unvisited and visited for a minute, because I'm not much from down there. So we say, okay, here's the new distance. If the distance map doesn't have it, I'm going to put it. Otherwise, I'm going to try to update it. So that's all method, because that's stupid. So this is Alt-Shift-M. And we're going to say update distance, so we're going to call that. Okay. So we're going to call update distance, and I need to pass in current distance. I can pull this down into here. Current distance, current distance. Okay, that's a little better. Okay.
Well, I'm pretty sure we do cache the.
Okay, so we mark a node as visited if we have checked all of its neighbors. So at this solve pancake, right, the current distance, let's... This is interesting.
Yeah.
So I probably want to update distance.
Because I know it starts with a blue screen to start, and it may check if there's updates. But
I probably want to update.
Exactly that. And that would make sense for us to.
It's on the first invocation, right? Well, I guess we're handling it. But we do need to put my distance map in for my current node, in case it's not there. It'll get put there. Yeah, we're just going to do it just in case. I'm not quite sure where we're at, but I'm just going to do it anyways. And I'll update distance on my current node, so origin. And it is going to be current distance. Okay, now instead of passing in something, I'm going to pass in the actual we want to do. That's going to be nuevo distance at this point.
No, we're going to have to hear about it.
Okay, and then right here, nuevo distance. That should be appropriate. Okay, so I've almost got this driver written so that I can actually start writing tests on it. But for now, great, so we're going to update the distance. Okay, so I am going to visit all of its neighbors, and once we've visited all of its neighbors, let's just say that visited dot add origin. So you are now officially visited. And right here, let's do this. If not visited, contains.
Okay. I know the name is open to that though. It might be.
That would be a good idea to do.
If not visited, contains a neighbor. We'll just say unvisited. Dot add.
And then you're also going from layer of dealing from.
Okay, perfect. Ooh. Okay, I remember how we're doing this. So, now we have all these unvisited set or visited. If it's visited, which is to say we have visited all of its neighbors, we're going to add it to the visited set. The unvisited set, when we want to check out the next neighbor, we find the node that is closest, so the smallest distance away from here. So we need pancake, and this is actually going to be a tree set in this scenario.
I really doubt that they're going to want
that to get ordered. Now here's the trouble. We actually don't want that. Let's just undo that tree set business. So we need a method which is get nearest unvisited pancake. So public pancake get nearest unvisited. Okay. So what we need to say is pancake lowest pancake is equal to null. for pancake P in unvisited
Yeah.
and
There's no pocket space in there. It is.
unvisited.
But then you have both of those written.
Okay. Create pancake P
Yeah.
in unvisited.
That would make
Um,
things simple, but
We want to say
the downside is
distance is equal to distance map dot get currently in P. Okay. Now, is distance map ever not going to have P in it? Okay. Equal to null. Then integer max value. Otherwise, distance map dot get P. Okay. Yeah, just in case it's not there, we are going to. Why are you complaining? Oh, because that's a then. Okay. A little bit ternary for you.
Our velocity's been pretty good on
Okay,
that.
great. Nearest unvisited pancake. And we'll say if distance is less than current lowest distance, then we say that lowest pancake is equal to P and current lowest distance is equal to distance. So clearly we need an int current lowest distance is equal to integer dot max value.
Yeah, I don't think it was really.
No, I want to stop the madness. Yep, cancel. Cancel. No one cares about installing instructions. Cancel that. Thank you. That was lovely. Max value. Cool. You good?
Well, I'll get these
So I
changes
want
up
to
and,
return
thank you. And
lowest pancake.
I have a
Okay.
quick fix to do
Okay.
on
So far, so good.
on this
So,
thing. Download.
if I start on my origin, right, we'll update the distance to the origin.
No, but it
If it's happy, we'll return it.
Yeah, it shouldn't be hard to figure
I
out.
have to do the saving and loading stuff.
Then I'll get all of its neighbors. I'll update their distance,
I would
right,
guess it's.
which will allow me
But
to.
the part I did,
Yeah, we add this guy to visited,
Yeah.
and solve.
So it does. It says
So what I
it
need to
does
do is I
work,
need
just
to
as long as
call
the path. I'm guessing
solve
it's just,
pancake on the next guy.
So I don't think it's a big deal.
Okay.
So
So
after
here's what I'm
that,
gonna
I'll make sure I have
And I
the.
have no tested. When we
Hopefully.
seen it in the wizard, was right now it's about one of the tested.
Int solve pancake. So what I'm going to do is I'm going to return.
Okay.
How am I going to know if this is a happy pancake? Right.
The
Let's
code
just do
is really
this.
the
Let's
same.
just call
Really
this.
good, just plump it in.
Because I need to solve all of them to know what the shortest
so I'll fix
path
that. I
is.
don't expect that to take a long time.
Right.
And I'm going to make sure you have them set so they can get.
So even though I found the happy one, that's not
after that,
actually
I don't know.
good.
I want to provide
Okay.
value for this UI
So let's
stuff.
just do this.
So
Public void solve
results
pancake.
that I can do. I think there's some image stuff
Cool.
we can do, pop up.
Right?
Research fonts.
And we're going to change this to
Yeah,
explore
that's what I was
pancake.
thinking. Do those.
So which means we're going to figure out its distance and check out its neighbors. Righto?
Okay.
Righto. Yeah, that sounds reasonable to me.
Cool. Maybe
Yeah, get behind that.
I'll
Get
get
behind
done,
that.
and then when we talk to maybe at 3, maybe
Okay.
we'll also be back. We can start working on that.
So update distance is here private. We're going to get the nearest
Alright, good
unvisited
job.
pancake. It's going to return the pancake. I don't know what it is, but okay. So let's just do. No, that sucks. Okay, basically, I know we all call this again, so for now. I'm going to get distance for this pancake P. If you return distance map dot get P. Not null. Okay, here we go. We're going to have private get safe distance. Pancake P. And we should do this.
I got her at least.
Turn. And the distance is going to be -1. That's our flag that it doesn't have it. Okay. And to get safe distance. That's just convenient, so I don't have to keep writing that garbage. Let's get safe distance for P. And the distance is greater than -1. Return get safe distance for P. Okay. Okay. That should give me the tools I need to start hitting this. So given one pancake, I can explore it, and then I can ask. So I need a boolean is finished, which is to say that nothing is in the unvisited set. Public boolean is finished. And return unvisited is empty. And visited not is empty. So if it's finished, visited will not be empty, and unvisited will be empty. Okay. And then I will say public int get shortest path. And I'm going to return, I need to know what the happiest. Okay, what if we should do this? Get shortest path. All I'm just gonna do is right here. So given one pancake origin, I'm just gonna write all this code right here. Now, I'm not writing my tests first, but I will get to them to verify this. Okay. So let's just say this. While not is finished.
Oh, Alan, I know why that is blocked. So
Let's just say explore
what's
pancake.
happening is in the code, there's the Zima, the way of loading things is going to be
Int.
just the only
Distance.
we have in grand, so that will just be loaded.
Equal to 0.
But
Zima is the exception.
it's the exception
Yeah.
for one of them.
I hate this so much, but let's do this. Distance map dot put origin 0. Great.
Yeah. So that's why it's doing that. So we can
Explore
say
pancake. We're gonna remove current distance from explore pancake,
actually let me see.
and we are gonna just pull it out of
I
the
already
code.
expressed that.
I can have to admit it.
So int current
You
distance.
can do it like if brand is not
Get
Zima,
safe distance
load the default, otherwise
with origin.
load. That's
And this
that's a little
update.
bit-
I was a flying sheep for a second.
Alright.
Update that current distance. If I don't exist. Yeah, I'm gonna count on you existing all the time, so I don't even
Yeah,
need
because
to
that's
call
it,
you
get
right
old
now.
default skin. And
Current
so
distance is get safe distance.
you don't have an old default
Yeah, that'll be
skin.
fine.
And
Can't get behind that.
Yeah.
Now, I don't want this to be orange, I want this just to be, what should I call it? Pancake. Okay. So, we're going to put it into distance map just so it works. And I can actually... Okay, while not is finished. Okay, new plan. Let's make a constructor. Public. It takes in a pancake P. Okay, okay, this dot origin pancake is equal to origin. Put P. Okay, I'm gonna set distance map dot put P and 0. Okay, and I'm gonna say unvisited dot add P. Okay, and I'm also gonna say goal pancake is equal to P dot generate happy pancake. Okay, so a couple things. Let's just make these really quick. So private final pancake, origin pancake. Do I even need to keep the origin pancake? Yeah, I do. Let's do it. So we have one of those. Private final goal pancake. Goal pancake. That's how I recognize what it is. That should do the trick. So I need this to create. Let's just say string happy is equal to. Do I have a string? Nope, I don't have a string. So I'm just say boolean p. Gosh, it's fine. I equals 0. I is less than pancakes. I plus plus. Pancakes of I is equal to true.
Dang, I threaded that needle.
Okay. Nope. No. So I need to fake that. I need to do that same thing right here. That's what I need. Boolean temp. There you go.
Alan tried log and stuff logs.
This time temp dot size length. We say temp of I is true, and then I want to return
Did you find him?
Yeah.
pancake dot from string. Let's just new pancake. Let's just pass in temp and our current flipper size, which we should know about. Good. Okay, let's add a test for that really quick. Test spawn heavy pancake. Alright, so let's just go plus minus. Great. And a size 8. Just Why the heck not? Assert equals pancake dot expected. Yeah, from string. Initial config is going to be plus, and then I got plus, and that's 8. And the actual is going to be p dot generate happy pancake. Okay, so that's how I know what the goal pancake is. See if that worked. Okay, that worked out great. Let's go back to Edgar. First off, let's put that up at the top, because it's silly not to have your constructor at the top. And in fact, this is going to be private, so we're not going to explore pancake from that side. Okay, and then I need these private final variables to go on up, because that would be insane not to have them up at the top. Okay, so here's the question. Do you put your already, like, initialized ones at the top or the bottom? Well, I'm going to put them at the bottom, because I want to see these things first. Okay. Okay. So if we go to our get shortest path method, it's already been initialized with the pancake. So while not is finished, we're going to say this. We're going to say pancake candidate is equal to get nearest unvisited pancake. If candidate is not equal to null, I'm going to call explore pancake of candidate. Great. Else break. Okay, now what should happen is we should explore all the pancakes with this, hopefully not doing too much madness, and then I want to return get the distance for goal pancake. Okay, this by all means should work. No guarantees that I implemented any of this correctly. I'm never actually keeping origin pancake anywhere, so I'm just going to go ahead and get rid of that. Okay. So let's write a test. And we're going to make an Edgar test, actually. I really need a new name for this, but I just don't have one yet. So Jane test case, Edgar test. Finish. Alright, let's do this. We're going to do pancake. Pancake p is equal to pancake.fromString. I'm actually just going to pull this right from the question temp they gave us, okay? Case number 1 right here. So that's what it's going to be. And this is 3 is what we've got right here. So the initial config is going to be right here. So let's put that in quotes. And that's going to be 3. Okay. So I've got 3. That works. And then we need to say Edgar is equal to new Edgar. And I'm going to pass in p. Okay. And then we say p dot find shortest path. Get shortest path? Dude, what the crap did I call that thing? I don't even make it public. Get shortest path. There it is. Get shortest path. Why? E. Get shortest path of p. Okay. Does that return something? Okay, so int distance is equal to that. And I want to say assert equals that 3 and distance are the same. Right, because that is what the test case told me is true. Ooh, okay, now here's the thing. You automatically inserted the dumb one, which is dumb. Nobody wanted that. So let's import JUnit 4, not 3. Okay, 3. And it's still running. Which is to say that my algorithm is clearly not working, so I need to show my console so I can make this madness end. So let's go show view console. Yeah, end the madness. Okay, so we're hanging. Well, let's just take a quick look at that. Get shortest path. Get nearest unvisited pancake. Yeah, that's fine. We're gonna find it. Right? Okay, then we're gonna explore that pancake. So current distance. So why am I adding you to unvisited? Let's just go ahead and because I'm gonna visit this guy. All right. So what we do need to do is right here, add this. Okay, so I kept adding myself to the visited, and what we need to do here is go unvisited dot remove this guy, no, me, which is pancake. Okay, now So if this has been visited, that's fine. I can still update it. Yeah, if I haven't ever seen it before, I'm going to add it to unvisited. That's right. And it's a freaking set, so that should be fine. So let's try the Edgar test again. Okay, that came back immediately with a 3. Mr. Dijkstra knew what he was up to, gentlemen. Ladies and gentlemen, in case, just in case, my one viewer is not Brian, but happens to be some female I am not aware of. Okay, so let's run a test case for the rest of these guys. There's another test that Google gave us. Case 2 should be 0. Oh, it's just the happy path. Okay, so it's that plus a 4. So let's just do that. Right, 0, 4. So we're going to test the already happy. Test the already happy. Let's test simple case. Okay, so this guy should be a 0. Let's see if that flies. And it came back as a solid 0. That's great. So now let's test this guy, who is going to come back as impossible. Not Kim possible, but impossible. So let's test impossible. Okay. Oh, garbage can. Would you not do that? Oh, okay, that makes sense. Oh gosh. Alright, that was like way too much work. Okay. I believe this should be -1. Let's try that. Okay, yeah, so impossible's coming back as -1. Alright, we got 4 minutes. Can we pull this off? Okay, so in our driver right here, we've got a pancake. I'm going to say int result is equal to new Edgar pancake dot, yeah, import Edgar dot get the shortest path. Oh, I'm passing in, that's what I'm doing. So I'm passing in that shortest path to the pancake. If I were to stash, yeah, whatever. I don't have time, but I should get rid of that. So let's just try and do that real quick. So when we go to Edgar here, we do want to say origin pancake. No, screw it. Screw it. We're just going to do it that way. Oh, sure why. Alright. Pancake. Alright, not my favorite, but it's whatever. I can make this work, but I don't want to. Okay, so hit result. And then I want to say so. And yes, so I need to write case space number and then the I plus I plus, and then what is it? Colon space plus result. Plus result. Let's try that. Now, so if result is equal to -1. Say impossible. Right? Is that correct? It's quite impossible. Okay. Alright. So then we'll just do this because it's going to incline as to how close. Right. Okay, so if I run this guy, run, see if my driver's working. Now I'm just going to paste into my console this input. Yep, to be lovely. Case 0 is 3, which I expected, and then case 0, and then impossible. So 3, 0, impossible. So it looks like my code is flying spectacularly. So let's go ahead and try, don't bother, let's try to solve a small. So we're down with that. Okay, that's my a small practice in. Okay, I'm going to copy all of that in. Okay, close everything. Let's run my driver. It'd be cool if this like read from a file and stuff, but I ain't about that life. Alright. I actually need to say case 1. Okay, so it's I plus 1 on that. My bad. So I need to output case I plus 1. Yeah, I know, that's annoying. I plus 1, and yes, that's terribly unreadable. But here we are. Okay, so we run it again. Run. Okay, paste it all. Okay, that's my output file. Copy that into Sublime. File save as desktop output.txt. Why the heck not? Okay. Now I want to choose a file from the output file. I might need a name, but I don't really feel like giving it the right name right now. So we just need output.txt. Hope that's right. Okay, and yes, let us submit it. Oh, I was judged correct.
Nice job.
I did it. Did it. Alright, cool. So we just used Dijkstra's algorithm to figure out how to flip pancakes, which is pretty legit. So let's just try a large, right? Or as I like to call it, the large A file. Alright, here's my large A file. Okay, that was fun. Let's close you. Let's run the driver. Here we go. Behold. Oh, you're taking a while, eh? Oh yes, you're large. Huh. Okay. Yeah, you're still doing a thing. You got lots of neighbors. Okay, so I will clearly need to optimize this for larger nodes, or larger maps, basically. Yeah, because every one of these pancakes is going to have 99 neighbors, and so we're going to have to visit all of its neighbors. That's lovely. Now there's definitely going to be a lot of duplication there. Dude, but that's taking a while. So really quickly, let's take a look at this code. I need to be done here. So we explore pancake. We get the pancake's neighbors. Okay. So this is a list. In this case, it's going to have, what, 99 neighbors or something like that. For each neighbor, we put it into the unvisited pile, which is fine and dandy. We update its distance, and then we move on. I don't know exactly a good way to speed that process up. It's just I'm sure there's something to be done. Alright, I'll look into it, and we perhaps will optimize this next time. Anyways, thanks for watching. Hope you all are doing super duper well, and yeah, happy Dijkstra's algorithm day. Catch you on the flip side. Bye.